This video is for Math 70, and this is a follow-up assignment on the rules of exponents. In the first video, we talked about these two rules of exponents. X to the a times x to the b is x to the a plus b, and why that's true. Same thing for this one. X to the a raised to the b power is x to the a times b, and again, we talked about why that's true. So today, we're going to look at dividing expressions that have exponents. So before I do that, let me talk a little bit about reducing fractions or canceling a common factor in a fraction. If we have something like 6 over 15, you can say, 3 goes into 6 2 times, 3 goes into 15 5 times, and so this is equal to 2/5. And that's all well and good, and it is true that 6/15 is equal to 2/5. But let's dig into this a little bit more and talk about specifically what's happening. Because what's happening here is that the 6 is 3 times 2, and the 15 is 3 times 5. So this is actually 3 over 3 times 2 over 5. That's why this is equal to 2 over 5, is because the 3 over 3 is actually 1. And there we go, 2 over 5. So that's the whole process of reducing a fraction, is to take out this redundant factor of 1 here, okay? All right, so now let's talk about the next rule of exponents, which is what happens when we divide expressions, exponential expressions with the same base. So let's say we've got x to the a over x to the b. The rule says this is x to the a minus b. Okay. Why is that? Well, let's look at it numerically. Let's say we have x to the 5th over x to the 3rd. If we follow the formula, it says this should be x squared. Okay. So here's x to the 5th. X times itself 5 times. And here's x to the 3rd. X times itself 3 times. Each of these cancel with each other because they each make 1, right? X, whatever x is, x over x is equal to 1. So here's 1, here's 1, here's 1. They all cancel each other out, and we're left with x squared. Okay? Let's see here. So what happens if we have a bigger number on the bottom? Well, we can also say that x to the a over x to the b is 1 over x to the b minus a. Okay? And again, the reason is the same. Let's say we had x cubed over x to the 5th. There's x cubed, there's x to the 5th. These three cancel, and we're left with 1 over x squared. Okay? So wherever the number is bigger is where you're going to have leftover factors of x. Okay? So those are our new rules of exponents. X to the a over x to the b is x to the a minus b. I guess we could also say it's equal to 1 over x to the b minus a, depending on which number is larger, the b or the a. Okay? In Math 95, we'll get into negative exponents, which is related to these ideas right here, but for right now, we'll leave that for the next course. Let's see here. Okay, problem 2. Starts out as 27 x to the 5th over 9 x to the 4th. So the coefficients, the numbers, we just cancel, same way that we cancel with a fraction, right? 9 into 27 goes 3 times. x to the fifth over x to the fourth. This cancels out all of those except for 1, and we just end up with 3x. Okay. Problem 4 is very similar. We've got 24y to the fourth over 8y to the seventh. Now, the coefficients are similar because 8 goes into 24 3 times. This scenario, though, is different. Okay, you've got more y's on the bottom than you do on the top. So y to the fourth will cancel out 4 of these and leave you with y to the third on the bottom. Okay. Let's see here. Problem 6. 25a to the sixth over 75a to the ninth. Okay, now, in this one, 25 goes into 75 3 times, and this a to the sixth will cancel out 6 of those a's and leave us with a to the third. Now, it's important to understand that this 3a to the third is on the bottom, and what's on the top, when you cancel everything out here, is 1. Okay, it's just like if you have 4 over 8, this is equal to 1/2, because 4 goes into 8 2 times, but 4 goes into 4 once. Okay, so it's important, number 1, to know that this 3a cubed is going to be on the bottom, and also to know that you need to put a 1 on the top when there's nothing left in your canceling. Okay, let's keep looking at these. Problem 8. 32x to the fifth y to the sixth over 8xy to the fifth. Okay. Now it looks like everything in the bottom is going to end up canceling out, right? Because 8 goes into 32 4 times. This x to the first will cancel out one of these, right? Following this formula, 5 minus 1 is 4. I always think of it as canceling out, right? So one of these x's cancels out one of these. We're left with x to the fourth. Here, 6 minus 5 is 1, so it's just y to the first power. You can also think of it as these 5 y's canceling out 5 of these and leaving 1 left over. 4x to the fourth y to the first. Now, over here, when everything canceled out, we had to put a 1 on top, right? Over here on the bottom, all of this cancels out. We can put this over 1 if we want to, but we don't need to, right? Because it's the same thing with whole numbers, right? 9 over 1 is just equal to 9. We don't have to put it over 1. But, you know, 1/5, you have to have the 1 on top. Okay, so you don't have to have the 1 on the bottom if you don't want to, but if there's got to be a 1 on the top, you need to put it there. All right, let's see here. Oh, these are getting more and more complex. Let's look at problem 10 here. 5x to the fourth, y cubed, and z. And then on the bottom, 30x to the third, yz squared. Yeah, okay. So, again, just like when we were doing the problems on the last assignment where I said, let's consider the coefficients separately, then the x's separately, then the y's, then the z's, right? Handle each one separately, do all the canceling, and then see what's left over. So, 5 goes into 30 6 times. These 3 x's will cancel out 3 of these and leave 1 left over, x to the first on top. Similar thing here, this y will cancel out 1 y here and leave 2, right? Y squared. Y squared. And here this z cancels out one of these and leaves us with z to the first power. So on top we have xy squared. on the bottom 6z. All right, well, now they get a little bit trickier. We're going to start involving this rule of exponents right here. Problem 12. We've got to apply those exponents before we look to do any canceling. Okay, so before we get started, we can't cancel anything that's inside these parentheses just yet. So let's go ahead and raise these to the third power, 125 x to the third power. Down here, 9, and then this will be x to the sixth. Notice how this 3, which is a coefficient, gets squared, right? But this 3 is an exponent already. X to the third squared is x to the sixth power, right? Because you do x to the third times x to the third. That's x to the sixth. Okay, now we can look to cancel. Well, we don't have any common factors between 125 and 9, right? But here with the x's, we can cancel these out and leave us with x to the third, or 9x to the third on the bottom. There we go, 125 over 9x to the third. Okay, similar problem in number 14. We've got to expand these and raise them to the power before we look to cancel. Okay, so let's go ahead and do that. So these all have to be raised to the third power. 2 to the third power is 8. X squared to the third power is x to the sixth. And here we'll have y to the ninth. This will be x to the 16th and y to the 8th. All right, so here these cancel and leave us with x to the 10th. And the y's cancel and leave us with y to the first. And so we end up with 8y over x to the 10th. Okay, let's see here. Problem 16. Got 7x to the third, 6x to the 8th on top, and then 14x to the 5th on the bottom. Now you can cancel these if you want to, right? They're in parentheses, but there's no exponent outside, okay? So we can cancel before we multiply these together. You can cancel after you multiply them together too, if you want to. So the 7 goes into 14 twice, and then this 2 goes into 6 3 times, okay? Let's see here. So I'm going to simplify first before I look to cancel the x's. We don't have to do that. We're going to end up with 3x to the 6th here. But on top, we've got 3x to the 11th. On the bottom, just the x to the 5th. These cancel out, and there's our 3x to the 6th power. So notice the difference, like I pointed out, between 14 and 16. Here, you can cancel because there's no exponents outside those parentheses. Here, you've got to raise those things to exponents first before you go ahead and cancel. Okay. Okay, problem 18 and 20 are actually both like problem 16. So let's go ahead and take a look at those. 18, 21, a to the 5th b, 2, a to the 8th, b to the 4th, and on the bottom, 14ab. Okay, so again, we can go ahead and cancel because there's no exponents outside these parentheses. So we can say 7 into 21 goes 3 times, 7 into 14 goes 2 times, and then these 2's cancel each other out. Okay? we can cancel this a with this a to the fifth and leave us with a to the fourth. And then these two b's will just cancel each other out. And so now notice everything on the bottom has been canceled. So what we're left with on the top is the 3, a to the 12th, and b to the 4th. And there we go. All right, problem 20. 5x to the 4th, y to the 4th, 10, x to the 3rd, y to the 3rd, and on the bottom, 25, xy to the 5th, and 2, xy to the 7th. All right. Well, let's see here. Again, no exponents outside those parentheses, so we can just go ahead and cancel. 5 into 25 goes 5 times, and now here's 5 times 2, and here's 10. Those are all going to cancel each other, however you go about doing it. We'll say 2 goes into 10 5 times, and these 5s cancel. Okay? Or this is 50, this is 50, 50 over 50 is 1, so they cancel. All right, let's see here. Let's clean this up a little bit. I'm going to multiply on the top. That'll give me x to the 7th, y to the 7th, right? 4 and 3 is 7, 4 and 3 is 7. On the bottom, we get x squared, and then y to the 12th. And now we'll go ahead and cancel. This will be x to the 5th on top, and looks like y to the 5th on the bottom. Okay, so that's it for the rules of exponents. We'll just have a couple more assignments before the end of the term. I will get those up and ready for next week, along with a sample final exam. As always, if you have any questions, please let me know. Thanks.